Good evening, everyone. Thank you so much for being here tonight. It's a little bit far from downtown, so thank you for having made the way to here. I will present you Shanghai in 15 minutes, and even though my presentation is 15 minutes long, that's not what I'm talking about. But let's keep the suspense a bit for why Shanghai in 15 minutes. The first thing I want to say is to leave you with some things about smart city. It's an opinion, it's not necessarily shared. But let's start with the beginning. So I'm a scientist, so what I will show you today is based on a scientific exploration. It means that I'm trying to create models, I'm trying to create hypotheses, I'm trying to find if there is any theory behind the city, and I will show you how I do it. So I will not show you nice results, I will show you ugly, on the way thing to show you how it really works and not hide the complexity of the problem. So I will start everything with traces. So traces is any activity, any human activity is leaving something, a trace. If it's a smart city, the trace can be digital. And if you get this trace, you can eventually, by using all these traces, which are from the past, predict the future. That's kind of the goal of a model. The model is taking a lot of traces, and from it predicts the future. And usually you mispredict the future because your model is not good enough. So then you have something that happens, which is the fine-tuning, where you try to refine given what you actually predicted and see it's not really like that. So you want to fine-tune what you have done. Okay, that's the traditional way of science. We get traces, we make a model, we see if the model works, usually not, and we go into fine-tuning. That's basically smart city. So keep that in mind, and I will go back to that at the end of the presentation. And now for the real topic of the presentation, which is Shanghai in 15 minutes. So the base of Shanghai in 15 minutes is based on a rule. It is the urban rule. The urban rule is called the 400-meter rule, and this rule is used by urbanists to say that a good city, or might say a smart city, is a city where you can access a public transportation system in 400 meters of wherever you are. So this is Shanghai bus lines that has been captured on Baidu website. And the circle here is 800-meter diameter. So if the circle doesn't cross any red line, it doesn't respect the 400-meter rule. And we need to add more to comply to the rule. So is Shanghai a smart city for the 400-meter rule? Not quite. But let's move forward for another rule which is smarter, which is the 15 minutes rule. So this rule is another rule which is used in urbanism, and basically the 15-minute rule is like you need to access anything important for your daily life in 15 minutes or wherever you are. Now we will question what is 15 minutes, and the rest of my presentation is a question on that. This 15-minute rule has another name. It's also called the walkable city. So the concept of walkable city is linked to the concept of 15-minute rule. Why the 15 minutes? There are many advantages. It's catered to elderly because they don't have to, they can move, so they are in better health. I mean, anybody who can move to the daily life facilities is in better health. So it's good for your health. It has been advised that it's pandemic compliant because you can control your community in 15 minutes, which is much easier than having a city that needs to move from one point to another all the time. It's good for your health because you need to move. It's good for it's better environment because if you walk your surroundings 15 minutes all the time, you will want to have a better environment around you. So it pushes the public sector to invest into your environment. And same for the fine-grained land use. If you know your surroundings very well, you will know better where you can invest. You will know all buildings much better, and that gives opportunity to have a better control over your city. So that's the 15-minute rule. And so the goal is like you go from somewhere and you walk, bike, mope, drive 15 minutes and see what you can encounter, and hopefully you can get your kids to school, you can get health, you can get culture, you can get a nice park, you can get things like this. Okay, in 15 minutes. So the goal is, can we measure that? Is it possible to measure this thing? So if you want to measure 15 minutes rules in Shanghai, what do you need? First, you need to set up a transportation system. Like, do you consider 15 minutes on foot, on bike, on subway, or do you consider this on car? Because different cities in the world have different habits. In US, probably people will want to take the car more than walking. So the 15-minute rule needs to be kind of adapted to the situation where you are. That's the first kind of problems. So choose a transportation system and see in 15 minutes where you can go. Second thing is you need to access something, and we call it POI, which is point of interest. And point of interest is usually a point somewhere, and it represents a school, a hospital, a supermarket, a shop, a bank, a bus stop, whatever you need in your daily life to address all your needs, right? So you need to have these two things. You need to have a way to get your transportation, and you need to have the list of everything you can find. Already there we have a problem, because where can you find such a list if you want to calculate this for the whole Shanghai? You can find one if you go to Baidu and you say, I want to have a shop next to my home, but if you want to have the list of every single shop in Shanghai, the list of every single bank, the list of every single school and hospitals, you will encounter some problems. So, is it really a question for Shanghai? Was my first question. Can we do that? To answer this question, I will start by going into a very, very Chinese question, which is the question of community, which is kind of a small neighborhood, and see how they can access POIs to see if there is a thing with this 15-minute rule. So to see if it's a thing, I will use the work of my colleagues from the sociology school. So School of Sociology, basically, they go to people's home and they ask a lot of questions, and they have a lot of details about these communities. So it allows me to control what I find about this 15-minute rule. That we can ask, are people more happy in this neighborhood? And if yes, is it linked to the fact that they have access to 15 minutes something? For that, we use like 5,000 communities in Shanghai. This is the communities where they are. So you see they are a bit spread everywhere. And then we will ask one question. We will just look at the primary schools as a kind of an example of this, just to see if it's worth it. My question here, is it worth it? If it's worth it, I will go full length, but if it's not worth it, I will stop here because I don't need to invest more time. So, for the next picture, I will use this method, which is called a tessellation. The tessellation is drawing a line. You put all your schools, the schools will be the red dot, okay? And you draw a line in the middle, exactly in the middle. So anything here is closer to this point, anything here is closer to this point. Okay, that's called a tessellation. So if you do that for the primary school in Shanghai, this is what you get. You have Shanghai here for the primary school, and here you have Paris. Notice anything? The density is slightly different. It's exactly the same area. It's exactly the same. In square meter, it's the same. So this is Paris, a large Paris, and this is Shanghai. So you notice that even though Paris is less populated, they have much more primary school diverse, and in Shanghai, primary schools are just located more downtown. So this is just to see where the primary schools are in Shanghai and if there is any difference between urban and rural Shanghai. Something that the Shanghai government is really keen to look at. Let's forget this one, even though the color are nice. Let's focus on this one. So on this one you have, how easy is it to get to the primary school close to where you are? And here you have the number in meters. So the blue one is urban space, the green one is rural space. Still in Shanghai. In Shanghai you still have urban spaces and rural spaces. So you can see there is a real difference between urban Shanghai and rural Shanghai. The access to the primary school for rural Shanghai is you need to walk like 1.8 kilometers, but if you are in downtown Shanghai, you need to walk maybe 400 meters. So there is a real difference in your quality of life if you are rural Shanghai or if you are urban Shanghai. So now let's see, because here we have a distance, but we don't have a time, we don't have the 15 minutes thing. So let's see how it relates to the 15-minute thing, and if we can move on to that. So, if I want to do the 15 minutes, I need more detail. I need to know how fast you can walk, where you can walk, how easy is it to walk, or bike, or subway, or do cars. And for that, we need a lot of data. The problem is data is not easy to find. It's easy to find one source. It's hard to get all the sources to do a kind of a multidisciplinary interpretation of it. So, I will start with foot, and the average speed on foot, it's quite easy to find on medical journals. The average speed is 2.23 meters per second, depending on who you choose, if it's an old person or if it's just a fit person. What about the quality walk? So for quality walk, we did a study in our institute, And basically we try to predict if a street is quiet or not quiet if you want to walk there. So to do this study, basically we take all the roads, we take the traffic, we take all the parks and the trees, we take all the shops from Tajong, and we take the pollution from AQICN, and then we look on the social media, we look on Flickr and Weibo, and we check everywhere people have said quiet. So if somebody in a street or in a photo say quiet here, we say that this specific road has a potential to be quiet. And then we learn what is the property of a street which is quiet. You do that for 10,000 streets, you predict which will be you predict the quietness, and then you get to this nice map where the green is the quiet and the red is not quiet. As you can see, inner circle, not quiet. That's not a surprise. Inside a park, in Century Park, it's quite quiet. It's not a surprise either, but that proves the algorithm is working. So we use this to have a quality walk in our 15-minute film. That's just one example of smart cities represent a lot of things. So this study here takes 3 months just to do this kind of a quiet thing. And it's just one tiny parameter in a lot of things just to check if it's easy to walk 15 minutes or not. It's just for you to realize like how complicated and how much time you need to just get to do all these things. And I'm not even speaking about the time to go to all these data sets, because each data set here is a month. For the roads it takes a month, for the shops it takes a month just to get everything. Weibo it takes a month just to get the data, not to calculate with it. That's for the walking and how we can improve walking. Now I will show you a little bit thing about mobike and the bike. The question for the bike, if you want to do 15 minutes, is how fast goes the bike? Like, because everybody has a different speed when they bicycle. So my question is, on average, how fast are you on the bike? And then we went to ask mobike, and mobike said, well, we have data. This is what the data look like. And when you ask mobike data, this is what they send you. It's a text. It looks like this. And I didn't change anything. It's just what they send you. And you can see here it's like 1,023,000 whatever lines. So this is what mobike look like. So you take mobike, you try to make something that look an Excel file from this. Takes some time. Then you put it on the map and you realize that there is this kind of ugly ink stuff. That's because when mobike give you the trace, they don't give you in order. They give you the points, but the order of the points is just whatever they made. So it's like 1, 2, 3, 4, 5, 6, 7. So if you look at the length of this, and you calculate the speed based on that, the bike will be super fast. But the real pass is like this. So you try from this, you try to make a pass that looks like this. It takes 7 hours with a clever algorithm to just go from this to this, get a normal length, get a normal speed, and then you can get the speed of mobike average in Shanghai. The speed average in Shanghai is here. It's like 3 meters per second. It's like 10 kilometers approximately. So 10 kilometers now we have, but the problem is, you can see here the map is quite ugly. It makes this kind of ugly stairs. That's because mobike, when they give you the data, they remove some of the precision from the location. And the precision make a kind of a grid. So this is what it looks like. Can you use the mobile data? Nah, not so much. But we use the mobile data to get the bicycle speed anyway and try to make kind of a clever 15-minute thing based on that. So for the rest of it, every map I show you is like this. It's a graph, and on the graph you have edges, and the edge have all these properties. And I use these properties to make maps. So this is the level of roads. Yellow is the low level, it's the pass. And purple is like a highway. This is bike safety, so purple is best for the safety and green is terrible. This one is for walk safety, purple is the best and the yellow is terrible. And we use all that to see like 15 minutes from here on a car, this is what you can access. Right? This is on a car, using the network, this is what we can do. So if I add now the bicycle and the foot, this is what we usually do for 15 minutes walk if you are a normal person. If you use the network with clever algorithm, the speed of bikes, the speed of cars that you get from mobile, you get a more refined picture. This is for the bicycle, this is for the foot, right? So you have some, like, this covers an area, and then you can count how many hospitals in each of these things. Like how many hospitals, how many shops in each of these circles. And then you get what you get from 15 minutes from here. It's on-the-go calculation. So, conclusion. I will finish here with a conclusion. I get some traces, and they are incomplete, they are bad, and they are ugly. Based on these traces, I'm trying to make models. The models I make are perfectible. I can make them much better if I have much more data. The problem is, it takes me a month just to get one source. For mobile, it took me 2 years to convince them to give me the mobile data. So 2 years of work to have something crappy. I cannot even get average speed based on this. But anyway, I have not so bad models. And with these models, I will try to make a fine-tuning, better model for my smart city. And then I can answer the question, from these traces, can I make a smart city? 3 takes to finish. I need a lot of different traces. So we need to publish more data, because if you want to have a smart city, you need to mix every aspect, the sociology aspect, the culture aspect, the transportation aspect. You need to put everything together if you want to understand it with a clever model. But that requires you have a lot of different traces. But if you do that, usually the answer is like, but if you do that, you will have less privacy. Not necessarily. Because the privacy, the fact that you send this data from your phone is just used for fine-tuning. For the first time we create the model, we just usually use a big data set, something big that has already been created. If you have the app on your phone that sends data, it's usually fine-tuning. Fine-tuning, we don't use it that much. This step matter, this step matter, these steps over there is the step where they ask you to sign up and send your data just to fine-tune. I think we can just skip this one and focus on this one to make clever models. So your privacy could be addressed, and we not necessarily need you to send all of the data all the time. You need to have the model, not the data. And I will stop here on that.